In this video, we're going to learn how to solve a logarithmic equation. Now, in order to solve a logarithmic equation, typically you have to rewrite it in exponential form. So right here, to get to the x within this logarithm, I'll rewrite this in an exponential form, which would be that 3 is the exponent. You raise 4 to get x plus 2. So we'll have x plus 2 is equal to 4 to the third power. And again, that log equals the exponent. So that's why that 3 goes up into the exponent spot. Now 4 to the third is 64. So we'll have x plus 2 is equal to 64. Subtract 2, and we'll get 62. Now, one thing you want to look out for when you're solving logarithmic equations is that logarithms have a restriction of domain, which means that certain numbers can't go within a logarithm. Anything that would make the inside of a log negative would lead to an extraneous solution. So here, if I were to check this, I would get log base 4 of 62 plus 2, which would be log base 4 of 64. And this should be a true statement because 4 to the third power is 64. So that does work. Now, typically when you're checking, you just need to make sure, as long as you did everything else correctly, just make sure that you still get positive numbers within the logarithm. If you did everything correctly, that's all you really need to check for. The reason why that may happen where you could get a negative value is because when we switch it to exponential form, it could yield a negative result or something that could cause a negative value on the inside of the logarithm. So you just have to check after you're done each time. Here we have log of 4x minus 3 is equal to 2. Now I don't see a base here, so it's going to be very hard to switch it to its exponential form. If you don't see a number, that's assumed to be log base 10. So this can be rewritten as 4x minus 3 is equal to 10 to the second power. Again, a log is equal to the exponent. So 4x minus 3 is equal to 10 squared, which gives me 4x minus 3 is equal to 100. Add 3, then divide by 4, and x is equal to 103 over 4. And if you need to make that a decimal to understand how big that is, you do 103 divided by 4. You can just plug that into your calculator. 103 divided by 4, and you get 25.75. But the fraction answer works very well as well. Now we have log of 3 minus 2x. Again, that's assumed to be log base 10, so we can rewrite this in exponential form as 3 minus 2x is equal to 10 to the negative 1 power. So that negative 1 is the exponent. Now, 10 to the negative 1 is a fraction, so we'll have to rewrite that as 1 over 10 to the first, which is just 1 over 10. And then we can subtract 3 and then divide by negative 2. So we'll subtract 3. So we'll have 1/10. And I'm just going to put that in red so it sticks out. And we're going to subtract that 3. So we need a common denominator. So minus 30 over 10. That is equal to 3. Subtract those two numbers. And we get negative 2x is equal to negative 29 tenths. And we can divide each side by negative 2. It's the same as multiplying by negative 1/2. They're reciprocal. It makes it a positive, but x will equal 29 over 20 when you're finished solving. Which again, if you need a decimal to understand how big that is, it should be just a little bigger than 1.45. Now we have 3 log x minus 1 is equal to 0.5. So what I can do first is add 1, because you want to get the log by itself before you switch its form. While it has all these coefficients and additional numbers, you won't be able to switch forms as easily as we have in the previous 3 examples. So we'll add 1 first to get 1.5, then we'll divide by 3 to get log x is equal to 1.5 over 3, which is equal to 1/2. And then we'll rewrite our number. So we get x is equal to 10, and that 1/2 is the exponent to the 1/2 power. Now we know that anything to the 1/2 power is a square root of that number. So we'll have x is equal to the square root of 10 as our final answer. Now as a decimal, the square root of 10 is 3.162, and it's a 10,000th with raised to the 4th decimal place. So that 7 changes that 2 to a 3, so 3.1623. Here it's already in that logarithms already by itself, so I can rewrite this as 2x minus 1 is equal to that base raised to the 1/3 power, that exponent that the log is equal to. Now, 8 to the 1/3 is also known as the cube root of 8. And the cube root of 8 is 2, because 2 to the 3rd is 8. So we have 2x minus 1 is equal to 2. Add 1, we get 2x is equal to 3. Then divide by 2, we'll get 3/2. Now, one thing I haven't been checking so far is whether or not these solutions work. But I can go back and check really quick on this. 1.45. I just need to make sure the inside of that log would be positive. So 3 minus 2 times 1.45 is 0.1, so we're safe. Log of 0.1. Log of 0.1 is equal to -1, so that works. Over here we got square root of 10, or that decimal. But if I were to check this, 3 log of the square root of 10 minus 1 is equal to 0.5, so that works as well. Even over here, 2 times 1.5 is 3, 3 minus 1 is 2. We are getting positive numbers within these logs, if you go back and check. Now for the last example, we have 4 and 1 we need to get rid of in order to switch it to its exponential form. So we'll subtract 1. So 4 log of 16 of 3x minus 2 is equal to 3. Divide by 4, and we get log of 16 of 3x minus 2 is equal to 3/4. Now that the log is by itself, we can rewrite this in exponential form as 3x minus 2 is equal to 16 to the 3/4. Another way you can simplify these rational exponents is to rewrite the number as a smaller number raised to a power. 16, for example, is also known as 2 to the 4th. So I can rewrite 16 as 2 to the 4th power instead raised to the 3/4, and now you can multiply those exponents. 4 times 3/4 is 3, so we get 3x minus 2 is equal to 2 to the 3rd, which is 8. And then we can finish solving. 3x is equal to 10, and x is equal to 10/3. And that is how you solve a logarithmic equation.